as you can see in the list up to the right in the screen, we are going to make a simplified programming wheel. I think I have a new idea on how to make the programming wheel removable and make the design really efficient. So the things we're going to go through in this stream is, does the pulleys need to be stationary or does the pulleys come off with the programming wheel? We're going to look at the music pattern, we're going to look at parameters, and then I'm going to CAD the hubs for the programming wheel. I'm going to CAD the bearing hubs and I'm going to CAD the axle and CAD axle hubs, and then we will be done with the simplified programming wheel. With me, I have, as always, Hannes 3000. How do you feel today, Sir 3000?
Well, it's okay. Who am I kidding? It's wonderful. As always, here we are. Another day in the dream factory. Ready to get some work done. I'm hyped, as you can tell. Let's get on with this programming wheel.
I got a little worried there for some time. So, yesterday we made the design requirement document. You can find it on the website. And one of the design requirements is that the programming wheel needs to be removable. To program off the machine. And I thought that basically my first idea I had was to make the pulley straight into the programming wheel. So yeah, we're now on step 1, pulley stationary of this stream. So I just want to discuss this a little bit with you and show you my latest thoughts about this. So I thought that we could machine the pulley straight in to the programming wheel. But then we wanted to make the programming wheel removable. And then I was like, because we have all these timing belts. Where are they? And I was like, I don't want to decouple the timing belts to remove the programming wheel because we have to fix this belt tension for every time we remove them. So then I went into this idea that the pulley should be stationary on the machine. And we have received a lot of great suggestions regarding how to design this. I thought we could look through them very, very quickly to just show you that when we leave the pulley stationary on the machine, things get kind of complicated. So let's take a look at the next one. Yeah, this is a cool suggestion for another stream. Next one. Next one. Next one. Next one. Next one. Next one. So here's one idea, the pizza mount idea. So here we are leaving the 2 pulleys on the machine, and then we need to index the wheel properly, which is kind of nervous. So let's just go through them quite quickly. Here's another way to leave the pulleys on the machine, and as you can see, we need sideways place here. You can't just slot it straight in. You need sideways place, and you need perfect indexing. The wheel has to come on in the perfect position every time. So let's just check next one. Here's also inner ring with slots, and let's check next one, and next one. And here's another indexing thing. This is a good point by TK that we can actually machine the inside of the drum and have it indexing very perfectly. But still I'm worried about position and stuff. And let's look at next one. And hub switching. This is also the things we have to figure out if we leave the pulleys on the machine. So let's look at next one, and next one, and next one, and next one. And I think we're, okay, no, next one. Yeah, so here we're also leaving pulleys on the machine. Let's look at next one. Next one, open, close. And these are great drawings here. The red wheel stays on the machine, and we can look at next one, which is from the same person. So if you look at the green disc here to the right, that is right next to the red disc. What I realized this morning is that however we do, we need to have kind of the same hub twice. So we need two sides of the programming wheel bumping up against each other. So just like in the Tesla Model 3, they had a top of the battery pack and a bottom of the floor of the car. And then they realized, like, can't we just make that one part? So they removed one whole sheet from the structure, and was like, the top of the battery became the bottom of the floor instead of having two sheets on top of each other. And when I see this, I feel like this is possible, but I feel like it should be only one part. So let's look at next one, and next one. And this is actually a good suggestion in how we could take back the Dragon Slayer 4 plates by using 80-20 structure. This could be possible with the new rotary CNC machine, but we're not going to do that. And let's look at next one. I think maybe that's it.
The last one. We have some underneath here. Just let me...
Yeah, so this is also a removable. You have to open the wall. And let's look at next one. Nice handwriting, by the way. Better than mine. Same style, but better than mine. And let's look at next one. Next one. I just want to show you what I mean with next one.
This is the last one.
Okay, cool. So thank you for all the suggestions. And what I've realized this morning is that if we allow for the belt to come off while changing the programming wheel, everything falls into place. It was a dumb design requirement for me that I didn't want to touch the belt tensioning. So I've actually made a little sequence in the design requirement document about how changing the programming wheel, the time could be. So release 2 belt tensioners, push 2 timing belts to the side, lift programming wheel off, lift loop wheel off, carry new loop wheel into position, put belt around new wheel at correct spot, drop new wheel in a bike fork, and tighten the belt tensioners. So this was all my introduction to saying that the pulley on the programming wheel is back.
Yeah, yo.
And I think this is going to result in so many great things, because we can machine this wheel on 2 hubs on a perfect center, and the indexing of the perfect center or the sideways position is always perfect. So there will be a shaft that stays with the drum. So when you lift it off to program the drum on the side, you can also rotate it on. So this is my new idea, and in this stream, I want to finish the CAD of this simplified programming wheel. So that leads us into point number 2, music pattern. I've started to look at the exact hole placement, and I CAD'd this morning. I only made 1 channel, otherwise Fusion freaks out. That's why we don't have these holes all the way around. And this is the same programming pattern as on the Marble Machine X, except we have tripled the amount of channels. More on that later. So I just wanted to check in logic here that our loop wheel, who plays the drum loop, would be able to play waltz on the triplet tempo. So if you're unfamiliar, this wheel is, as always, nothing to think about, but I had to check that if this wheel, who plays 8 times faster, could play waltz tempo on the triplet pattern. Let me just remind everyone, because this is pretty amazing. So what you hear now is the crank turns. 5, 6, 7, 8. So this is the tempo of the crank, and this is 64 beats. So you can see that we're repeating this 4 times. And then here's the triplet pattern. So now it sounds like Star Machine, like. Good, I can't, can't even play it because I have CAD in my brain. And the magic thing that happens when you place a waltz on the triplet pattern is that the waltz can go on the loop. I can mute the kick drum. So if you program the waltz on the 8th or the 16th pattern, the waltz will not loop correctly. So listen here. Here comes the loop. 1, 2, 3, and loop. And it works. So, and now I checked. So this is all on the top wheel. But this channel here is the loop wheel. And I checked if that could also play waltz. And it can. So you can see that I've looped this 8 times because it revolves 8 times when the top one only go 1. So if I play a waltz tempo on the drums, it plays perfect with the waltz. So if here's a crank turn.
Oh.
So I have to play like in between the strokes. And then I wanted to check if we could play an even slower waltz. And then I wanted to check if we could play even slower on the loop drum, and we can. Let me put this waltz on. And so what we're hearing now is actually this lower wheel right here. Okay.
Wow, bravo, sir! Bravo!
It's not me, it's the machine. So what I'm very happy about with this is that the loop thing is working out also in waltz tempo. So maybe something I should actually... This all sounds like, yeah, what are you talking about? There's not a problem. I should actually just show you that there is a problem, because if we didn't have the triplets, the waltz would be programmed. Let me change the subdivision to 16. Let me just put the same pattern, but on the 8th notes. So I'm just gonna repeat this chord. So wait, that's not correct. Let me just do this. So let me just check here. Where was I? What happened here? Oh, it's this one. So I was here. Boom, boom. So if I would make a waltz on the normal pattern, it would sound like this. And that's all fine, but not when the loop is looping. Because we're gonna do this, and I'm gonna put loop, and this is not going to loop well, because mathematically it's not. So this is a like old thing. So here, by the end of the loop, the bars are not ending up perfect. So we can listen.
Ah, okay.
Did you have that? It
Yep.
cut the tempo.
Yep.
And it's like 19 bars or something, which is not a musically usable loop length. And that's why we are doing waltz on the triplet pattern. That was just a little intro to the programming wheel pattern.
So nice to hear some music, you know? People are really happy.
So we're done with that explanation, and this is we have this triplet pattern. And this is actually the stylized programming pin pattern. Since we have round programming pins on this machine, I can have them much, much tighter, which is amazing. So that pattern is the same pattern as you can see here, but I made the holes. So let me quickly show you the parameters I'm using for this design, because this I redid this design from scratch this morning. And I'm using stuff like number of programming channels, and I'm using channel center to center, and I'm using like HDP stock diameter and HDP wall thickness. So basically, if I haven't decided yet how many channels we're gonna have on this machine, but if I go in here, let me stress test this now to just show you. And if I say number of programming channels is not 55, it's only 30. Oh, I can't edit the parameter here. Never mind, I'm not gonna do that yet. Anyway, this is a parameter-driven design. So that was all the intro. Let's get to some real work on 3000 by CADing the hubs. So the hubs will stay in the wheel, and they are going to be screwed in from the top. So there will be no machining done from the side here. I checked with Alex, the CNC machinist, and he said that might be complicated. So all the machining is done from the top. So let's get some CADing going on the hubs. And we will be able to drop the wheel into the machine, and it will stay there and just take it straight out. No adjusting, no screws, nothing. It will just drop in place, and we can just lift it out by the end of this. What do you think about that 3000?
Total brilliance.
So how are people in chat? What are they thinking?
They really like you playing some music. It was really nice.
Nice. I want to play...
The Uncle Pecos. Martin, I love it that you're aching to write new music. Let's get this machine done and get to write music. Let's go!
You sound like Hannes 3000 now.
Apfel Musking. Can't wait to hear the first sounds of the machine. People are getting excited.
I think I want to make a lot of waltz songs on the new machine. We never saw that on the marble machines. We only had 4/4 songs. Now we have this again. Oh, okay. Thank you.
We have a question here.
Yep.
From Mr. Jeff. Former Apple engineer here. Whoa. I want your success, but I'm nervous that the project is gaining features over the MMX. Why not just perfect the second try? Not against a redesign from scratch, but what if we add no new features? Otherwise, this one may be a prototype as well. The MMX only counts as a prototype if we stop adding features. Again, all love, only seeking success. You inspired me to start my own musical gizmo biz.
Fantastic comment. I've learned that you're absolutely correct. The previous machine is only a prototype if we're using the features that was on the machine. First of all, we're removing a lot of features from the Marble Machine X. So that gives me a little confidence in adding some other features. So we're not adding and keeping all the features in. In the design requirement document, we're listing actually a lot of things that we're not using. But I felt the Marble Machine X was so far away. The Marble Machine X looks like it was on 99%. I think it was on 20% near completion. So that's why I don't want to base this machine on the Marble Machine X design. And when we look at the two machines, we can see how similar the first two machines were. And you can see the muting levers and everything, and both failed. So, but your point, I'll take your point to heart, and everyone else should as well, that anything that has not been prototyped is a huge risk. So I take that point to heart, but I really want to exclude like magnet, demagnetizer, marble lift, planetary gear, conveyor belt, kinetic fingers, all those things, electric motor, all those things are taken off. So I hope we have some space for new cool features, good features, because we're removing like so much clutter from the More Machine X.
Removing so much pain.
But your point is I'm absolutely correct. And on the More Machine Maker Kit project I worked on during the break, we built 3 prototypes so far. And everything that I knew I introduced from the previous prototype failed. So I worked on that for like 4 months in CAD during the autumn. And I experienced exactly what you're saying. And cool to hear from you. Okay.
I just want to say hi to Zap Andersson. Hello, a little shout out to you. Giving us some shout outs.
Nice.
Mr. Jeff, I believe in you, Martin.
Thank you.
The former Apple designer here.
Uh-huh.
Yeah, he follows up with, I believe in you, Martin. You will fix it.
Fantastic. And I'm really taking your comment to heart. And I love doing these live streams and in a digital model because I can actually implement good real feedback now. So now I should be able to use my parameters when making this first hub. So I'm going to set the outside circle, and instead of just basing it on this, I should be able to do it off parameters. So I'm going to say that this circle is HDPE stock diameter minus HDPE stock wall thickness. And probably I have the radius now. Wait. Let me redo that. Stock diameter. Yeah, okay, it just didn't update. Good. So, and then I do minus HDPE wall thickness. Let's see if that makes sense. No. Okay, I need to do that twice. So a parenthesis. I need 2 of the wall thicknesses because it's diameter and not radius. Times 2. And now you can see that this line is perfect with the programming wheel that we made before. So if we go with something else, this will update automatically.
Mikael Damjunker, hi Martin and Hannes 3000. So cozy to have you in the background talking while I pretend to do a lot of project design.
That's fantastic.
And Zap Anderson again chimes in here. Solenoids and MIDI. Now that is a simplified programming wheel.
Until you calculate that you need 50,000 solenoids.
On paper, yes.
And before that, you need 50,000 channels to control the solenoids. Before that, it's absolutely simplified.
Yeah, but thanks you, Zap Anderson. Thanks you. I'm great at language today.
No one in the world is better on being you than you are, Hannes 3000.
Well, that's true. Thank you. Thank you.
So yeah.
Atski, since you are getting rid of the electric motor, did you consider using a speed governor to maintain the tightness of the rhythm, like is done on gramophones, music boxes, and steam engines?
Yeah, so we have gone deep into the governor question for years, and we have decided that you can't get it precise enough mechanically. If you can show how, you can basically just do a top governor that starts to add resistance on the top, but that will not be pleasant to play, to just give everything and reach a resistance thing. So if you have a mechanical solution, please post it. You find the upload links on our website under the Marble Machine 3 section. I'm making the spokes here. So I would love to see that. I've been thinking a lot about it. But from everything we have found so far, it can't be done actually. Most often those things are meant to open and close a valve. And that's just not giving us the precision we need.
And people are trying to correct you here on solenoids in chat. You only need one per channel. So if you have 38 channels, you only need 38 solenoids. I don't know anything about this.
Yeah, so then you don't have a programming wheel.
Yes.
So
what are we doing here?
And the quote was, that's a simplified programming wheel. So if you take the quote by word, it was implying that the solenoids were sitting in a wheel and not on a long row.
Okay.
So no electronics is also already in the design requirement document. So I don't want to have electronics. I want this to be the best sounding, tightest mechanical music instrument created in the history of the universe.
Yeah, small task.
So here is another great example of how I can use the parameters. So I'm here on this radius, which will decide the spoke thickness. So if I make it, or the rim thickness, but I should not just make it random. I should make it related to this one. So simplest way to do that is to take the complicated function I made before with all these parameters here, and I can just base it off of that. So I'm hovering over, and I see that it's D178. So I just want an offset here. So D178 minus 30 divided by half. Otherwise it comes on the outside. There we go. And then I can go into this thing and just add the difference here. So I want it thicker, 60, 100 maybe. Oh, something like that. And now this line will follow this line. This line will always stay 10 centimeters inside this line when we change the global parameters. Looks good. So the solenoids falls, for me the solenoids falls into the MIDI keyboard. It's cool, but it's a glorified MIDI keyboard, kind of. Not really. I think I'm being facetious if I only knew what that word means. Can you check what facetious means, Hannes? 3000.
What did you say? Facetious.
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 Yeah, try to spell that.
Facetious?
F-A-S.
Facetious.
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 I don't think there's a T. So I'm going to create a circular pattern here.
Fastidious.
Fastidious, is that one? Very attentive to and concerned about accuracy and detail?
No.
No?
But that was absolutely not that one.
Never.
Never. Very attentive too. I'm gonna make the spokes a little bit thicker, and check here, I can only change this one value and all the spokes are thicker now because we have CAD'd this in a nice parametric way.
Facetious.
Facetious?
What's that meaning then?
Facetious. Facetious.
Fasciitis. Treating serious issues with deliberately inappropriate humor.
Yes! Perfect. That's the one. That was so funny. What was the first one? Fastidious.
Here we go. I thought fastidious.
That was like being super serious about something, right?
Yeah. Very attentive to and concerned about accuracy and detail. That's what we should be, right?
And then read the other one again. That was too fun.
The new one?
Yeah, the facetious.
Treating serious issues with deliberately inappropriate humor.
Okay, I think that's funny. Facetious, not fastidious.
Facetious.
Facetious.
Hard word to say.
Yeah. Okay, we have a hub, and before going further, I want to find the bearing. So if you look in my list up to the right, next step is CAD bearing hubs. But I actually want to go a little bit ahead of time and start to look at some bearing hubs already now, because I deliberately did not put a center hole in this hub. But if we go out here, you can see now how simplified this is. And I left space here before I started the programming channel to have place to screw this in from the outside. And what I love most with this solution is that the whole wheel will be machined on the very center, which it will rotate around on the machine when it's done. So I think this is a very, very important point, that all the other solutions demand us to hit that center later. With this design I'm making now, we're machining it around the perfect center on the rotor CNC machine that I'm showing here, and we're leaving that center on for the rest of the lifetime of the programming wheel. Do you see the difference, Hannes 3000?
Yes.
Good.
Of course I do. I see everything.
Good. X-ray vision. So let me also light up CAD bearing hubs, because now we're gonna do both 0.4 and 0.5 in this live stream at the same time. So let's start a new component. 0304.
Gonzonator says, that's a tight fit. How will you squeeze it in? Are your perforations a bit too close together?
Yeah, so this is an interesting question. So let's look at these holes here. They're actually not all the way through. So I'm gonna show you the whole geometry from the side. Let me just...
Have you saved in a while, my friend?
Yes, there we go.
Great.
Good point. Let me show you the sketch for the center line holes. So this is the geometry of the hole. And as you can see, it's not going all the way through. So the pins are only going down to here, but then we're drilling a vent hole because the pins are going to sit so precise. So if the air can't get out, you will not be able to push them in. So structurally for the wheel, this CAD is a little heavy, so it takes a little time. You can see that the holes are smaller on the inside than what they are on the outside.
Oh, yeah.
You see that?
Yeah.
Let me hide the hub and it's easier to see. So on the inside, you can see that the structure of this HDPE barrel is not going to be an issue. And since we have round programming pins this time, I think we will get away with this. the wall thickness of the plastic on the smallest place is sub 1 millimeter, but I think we're gonna get away with this because that's this little wall thickness right here, 0.5 millimeter, which is very, very tight. That's not the thickness that's gonna take the force from the programming pins. Because the force is this direction, like alongside the circle. I think we can get away with it. If not, we have to increase. I can actually show in the flat sketch.
Alejo Lab.
Yep.
Can you put the hole for the air in the pin to save the integrity of the wheel?
Oh. Cool comment. Let me head over to the design requirements, which should not be treated as a design document, but I have a section which is sketch texts here. So this is just a brain dump place, and I'm going to put your comment in here. I did not think of that. Brilliant. I don't know if it's practical.
It's a cool idea.
Vent hole for prog pins could be in the pin themselves. Pins themselves.
Hashtag tube pin Android 78.
To make structure more rigid.
Also, people say that you don't need vent holes if you use spring/slotted pins.
No, exactly. So that could be something. So here is the sketch pattern, the flat pattern of the programming holes. And right now I have the... so let me show you quickly. Here's the hole notes. So I'm lighting up the hole note here. Here's the 16th notes. No, it's not whole notes. And here's the two triplets. This one and this one. So what we could do is that we could increase this to 2 millimeters. And then you can see that the holes are more separated. But the channels are closer to each other. So I think this is something that can and should be tested in the material itself to see how the material is reacting to having these holes drilled so close to each other. I have a feeling it would work.
Do we have a cheers here?
Cheers, Wilson.
Cheers, Martin. Cheers, everyone out there. Cheers, Wilson. Hope you have slept good tonight. Yes, I was dreaming about choking you in your sleep.
Whoa.
Whoa. Dark. Dark, Wilson. Dark.
Yeah. So let's get to this bearing hub right away. I'm going to, this time around, use standard part for bearing hubs. Yay! Standard parts. Bearing hubs. What is this? I meant a flanged. Quick disconnect. Oh, there's so many cool stuff.
Damn.
This is not what I wanted. Flanged bearing hubs. Oh, bearing housings it's called. Hub is something else. Bearing housings. Here we go. And I think I want the 2-bolt flange mount or 4-bolt flange mount. That feels right. And I want metric. These are ridiculously expensive. They're so overkill, Hannes. But
that's the name of our game.
yeah, these are the only kind of sponsorships I want. Like, just send me these and I'll say your name the rest of my life on all my live streams. They start at 20 millimeter. These are ridiculously overkill. How much do they weigh? Weight is not in here. $100 each. It's
Jonas Lindblad, why use American hubs when we got SKF in Sweden?
yeah, because SKF is not in McMaster car, and SKF doesn't have immediate. Believe me, I want SKF into Fusion 360. So grease fitting included? No. Oh, so now I have one that costs $252.
Boom!
So let's do yes. If it's cheaper, I want it. The thing you get from these though is that you will hold. You get some sideways alignment better, I guess, from these. Maybe there are other types.
Gonzonator said, just steal some of an old bike. They can take a whole person's weight.
Yeah, so that sounds extremely complicated time-wise.
Jonas Lindblad here again with SKF. They got step files for download. SKF. Baba boom.
Baba boom. Can you send the link? The web link, if it's allowed?
I don't think people can post links in chat though. Upload it to Dropbox.
But you can post a link without making it a link.
An unlinked link. There we go.
Okay, I'm just gonna take this now as a first step in the correct direction. But look at this size. This feels super good actually. This is like some real stuff. But is the bearing? I don't understand. Is the bearing included already? What is this? I never worked with these. Is there a bearing in this? Oh, and you can already lock them like this. Oh, this is a nice part though. Mounted ball bearing with 4-bolt flange. So, I love it. Don't you love it?
It's unbearingable.
I'm gonna take this measurement from here to here. Metric. Non-metric. Now I want SKF bearing housings.
Bring it! Bring it! Oh, sorry. Wow. That came out of nowhere. I can't bear this.
The SKF one. So let me join. Where should I put this then? I guess that could work. So let me do a joint between the outside. And what's cool with this is that we're gonna hide them on the inside of the hub, I think. Or do they have... No, wait. I'm gonna choose another point. Let me hide this monstrous wheel. This is, of course, the side that should be... Yeah, and then we can make a POM. Okay, I got it. This should go on the inside of the hub. Here. And then what I missed another day in a live stream is that when you make a joint and it comes on the wrong side, you can just flip it. Now it sits correctly there. Boom. This looks like engineering, right?
Yes, Martin, you are doing engineering.
I learned that engineer is not a protected title like lawyer and stuff.
Oh.
So anyone can call themselves engineer, but not anyone can call themselves a engineer.
No.
Only you who are here today are entitled to that title.
That's true. That's true.
So I really want this pattern to be in the... Let me see here. I'm gonna take this measurement, this ugly imperial measurement. Jonas is cringing in the chat together with me and all the Europeans and the rest of the world. But as I said before, I'm trying to take Marius's attitude to Imperial and just say, just learn both and don't complain.
Yeah.
It's not going so well though for me. So this distance should be pasteable. There we go. And then I should be able to make this a circular pattern with 4 instances, and we should have our bolt holes. It's in the wrong angle. I can
Bolt holes. I love that. The sound of that. The bolt holes.
You like bolt holes?
Bolt holes.
Let me take this 10. Why is it 10? It's an M10. This is oversized and nice. So it's an M10. Let me fix that. I'm trying to fix this with only one sketch. I don't want to... Let me angle this 45 degrees. Boom. Oh, and we can we have countersunk screws from the outside? Let's make these holes 10. So now I think we've done this correctly. I'm gonna not extrude these 4 holes. And that works. So I'm just gonna open the middle as well. So I want place for a POM bushing here. That will take care of the sideways distance. That's gonna be awesome. So I want, let's say 50. That's more than enough. Let's do 50. And the POM can be 40. 60 maybe even. No, 50. Okay. And let me also remove that.
Oh, wow. I'm just navigating the SKF website here. They actually have CAD models of everything here you can download if you know what you want.
SKF will be even more expensive. But of course, I am born in SKF's hometown.
What? Is it there?
And SKF makes so much commercial on Gothenburg Airport. I think your focus group is right here, SKF. Send me some flanged bearings, and I'll sell your stuff the rest of my life. SKF is a really, really cool company. So, can someone find this flanged bearing on the SKF website? And then I'll change it to an SKF one.
Wow.
And then I'm gonna call them live on stream. No, joke. Oh, I love this. I think this looks great. And I think I want to keep it very flat on the outside here. So let's make these plywood holes countersunk. So I actually think this is going to be plywood. It's not gonna move. It's gonna be perfect for all eternity. I think so.
Yep.
Let's chamfer you, 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 and you. Like that. And then we're using countersink hex bolt heads to put that on there. I love this. This is great. So let me try to finish point 4 and point 5 at the same time here.
Oh.
If I... I was wondering if I needed to do different hubs on the different sides, and now I think maybe I don't. So I'm gonna create a mid plane.
MBJ, the bearings are cheap as dirt. 10 to 20 euros standard.
Oh,
What?
nice. These ones? The ones I'm using?
I don't know.
Maybe it's just McMaster car. Oh, it's like top of the line crazy stuff. Mid plane. Prog wheel mid plane. Look at this, kids. I'm naming my construction planes, okay? So should you. So further down the line, we will be able to simply mirror these two components, the left hub and the bearing hub over our mid plane, and we're gonna have the same thing on both sides.
Ba-boom.
Oh, this looks so pretty.
Like you. Whoop, whoop.
So before I'm fastening, I have to, okay, no. Let me stay on track here. Now I have to fasten these plywood things into the plastic. And I have to think about these teeth right here. So let's do that. Let's hide this. Because I want to screw from the outside. And I want to make screw holes between these teeth. We don't need millions. And we can drill them on the rotary CNC machine. So everything is designed for manufacturing on a machine, something like this. So let's say, I know there's 200 teeth. Let me find out where these teeth are. How should I build this sketch up? I have to just think a little, Hannes.
Uh-oh. Put on the loading screen.
Okay, so I can use... Maybe I can use the tooth sketch to place these holes perfectly. So we have... We have this top sketch here. Oh yeah, this is the one to use. So let me hide the body. No. Let me project the side of the body here. And then hide the body. Now I want to find a position 9 millimeters in from the edge, so these screws are hitting the center of the plywood. This is not okay, I'm gonna get a point. I have to think about angles. 9. So my brain is messed up because we're not on a flat surface. We're on a cylinder. So if this is in the middle, this is in the middle of the top of a tooth. Okay, I put a point here. Okay,
Okay, chat is trying to send a link to SKF bearing housing, but it gets removed.
yeah, so don't make it a link. Just make it easy for Hannes to read it.
Yeah, just give me what it's called. I can find it.
So just put a space in like before.com or something, and I think YouTube should approve it. So just like, and maybe we should start to approve links. Should we just try that, Hannes?
I don't know if I can actually. We tried it on another stream.
Did we?
Yeah.
So, Fusion is computing. Done. Looked like it was done. I'm just trying to find. Yes, this will work. So now I have my point, which is on the middle of a tooth. And now I'm going to create a new sketch plane. This design is getting a little heavy, so bear with me while Fusion is a little sluggish. Now this should be, yeah, this will work. I can mirror the feature over the mid plane by the end. Okay, I'm just trying to think a little 3D chess here. 4D chess? What's the expression? Plane at angle on this line, like this. New sketch on this plane, like this. Project our point that we made, like this. Hide all other sketches. We actually also want the center line. Project the center line like this. Now we can hide everything else. Isolate the thing we're working on. Why am I not seeing this? Oh, it's here. So now I can calculate half a tooth distance here by putting in the angle. And the angle is 360 divided by 200, because we have 200 teeth. Put that in a parenthesis and divide that by 2 because we want half a tooth distance. That looks spot on. 0.9 degrees something.
Okay, so... Oh, no, what happened there?
And now if you look here... Oh, this looks good. So you can see that this line is coming up in the middle between 2 teeth here. Oh, I'm stupid. I put it... I want it... That doesn't look right. Or is that right?
Just gonna show you here really quick, Martin.
Yeah.
We think it's this one.
Ah, that looks great.
And there you have down here.
Yeah, you can upload step file.
And there you also have the CAD model
Brilliant.
that you can download in a lot of different formats.
The shaft looks very small. Is it 20 millimeter shaft?
Oof.
Up bore 12.7. So that needs to be that needs to be 20. D needs to be 20.
Okay.
It
They
looks like,
probably have it.
yeah. Super cool.
Cool.
Super cool. Meanwhile, I'm in the wrong sideways plane here. On my... How did that happen? Oh yeah, because I'm on the inside. Oh wait. Let me see what I can do about that. Yeah, I'm using the sketch before I made the part thicker. I'm using it. I tried to be too fancy. I tried using a sketch very early in the design process, and since we're doing some tricks with this pulley, I should have just added another sketch by the end. So let's just do that. That's okay. It's actually completely fine. Let's do an offset plane in from this edge. -9. There we go. Make a new sketch on that plane. Project a little point, and we are. Now you can see how this point ends up correctly between the teeth on the other side of the pulley. The herringbone timing belt pulley. So let's isolate everything else. Now we can drill our screw holes.
Just gonna show you really quick. This looks more like it, right? There you have the bore 20.
Yeah, awesome.
Woohoo!
So upload it to Dropbox would be fantastic with like the part name or something in the title. Super cool. And we have a crash.
Uh-oh.
Uh-oh.
Ba-ba boom.
I'm going to fix this.
That's stuff that happens. Oh.
I'm gonna try to race to get this done. I'm just have to fix restart Fusion 360 and hope it's saved a good crash file.
And Chad is really trying to help. They're so nice. They're sending a lot of. They're trying to get the links in and just sending their model number and stuff like that. Chat is on point as always. You beautiful, beautiful humans out there.
Yeah, thank you so much. It's so much fun and really, really helpful this time. It was helpful last time as well, but I couldn't really act on good advice. We're back in business in Fusion here with the programming wheel parametric recovery file.
Oh yeah.
Sounds like something we like. Yeah, it doesn't look like I lost the last plane. That's no biggie. So let me try to... It's tricky. Sometimes when I try to rush, it takes longer time. It's the slow is smooth, smooth is fast. It's that old thing again. I really want to show you how easily this will be put in and out because it's really, really easy. Let's make a sketch here. And let's project our little friend there. And our little friend there. So now I can make the revolve trick again. So I'm just going to design the hole here, and we need to put these screws in and then machine on top. So I'm going to do a counter bore, which is pretty large. What's happening now? Why? Fusion didn't like putting that line there. It's a little buggy sometimes. You have to kind of just love it for what it is, right?
Yeah. With all its flaws.
Yeah.
We can't all be perfect.
True love. So we need a bigger hole and then a smaller hole for the screws themselves. I guess this will be wood screws. So let's go with... here I'm going to put in the thickness of the through hole. Let's go with like 2. So there's 4 millimeters thickness. And this should be, I guess, 5. Something like that. Let's do this 12. And then this 5 is enough. So this took a little time because I needed to get this hole into perfect location between these teeth. And you're probably gonna cringe a little bit when I'm cutting the teeth open soon here. But we have so many teeth on these pulleys. So a little different geometry on one is not gonna make a difference.
Zap Anderson. I saw the original marble machine in the Spillclock Museum in Utrecht.
Oh, wow.
I climbed the Utrecht clock tower and I nearly bumped into Malgosia on the way up. Malgosia, now that's a proper rock star right there.
Cool. If you haven't seen the video, Malgosia is playing the marble machine song on the Domtoren clock tower.
She's amazing.
Do you know there's a Quidditch team called the Domtoren Dementors?
Oh,
I met a girl on a tram once and we started to talk to each other and I was like, where are you going? She asked me where I was going actually. So I was like, and where are you going then? Yeah, I'm going to go play Quidditch. Oh, so what's your team called? Domtoren Dementors. And I was like, hell yeah.
That's pretty badass.
That is awesome. So here's our...
Team captain is Malgosia, I'm sure of it.
Yes. So here, our painstakingly long hole is there. And now I'm going to make a circular pattern And it's going to, as long as we have it even, I think it will end up nicely between the teeth. We can check. So I'm gonna take a circular pattern around. I'm trying to use this origin axis for this, so everything stays healthy. Can you let me choose it? There we go. So now we can just choose how many screws we want, and we have to just make sure that it's end up. So here you can see here, this doesn't end up nicely. So let's try 4. And there we go. You see it end up between the teeth. So 4 is, I think, a little cheap. Let's try 8. And 8. 8 should be plenty. So let's try that. Yeah, it ends up between all the holes. So that's good. And now we can just mirror these 2 previous features. I don't have a good timeline. I should show the Fusion timeline more in the streams. So what I'm doing now is that I'm hitting mirror, and I'm mirroring features, and I'm mirroring these 2. First the revolve and then the circular. And if you remember, we made the midplane, and I'm choosing it from the browser. I know that's the one, prog wheel midplane. That's why I named it, remember?
Oh.
And now we're gonna go on the other side and get, look at this, centered and nice. We're getting the holes on the other side, and we're getting somewhere. And I think I will be able to finish this before the stream is over. So.
Got a valid question here from Fredward. If you cut the teeth, how will it eat noise?
That's a very good point. So now we have screws attaching these hubs to the thing. What we need now. Oh yeah. So now we have to celebrate. So when we move on to the next thing, we're gonna move to the CAD axle, but not until we have celebrated. Yes!
Wow!
We whacked that mole. Let's whack the CAD axle mole. And here, my friends, I'm gonna become a little self-proclaiming, self-righteous. I don't find the word. Axle. Using a master sketch and revolves is brilliant. So this whole design is based on this one sketch here. So now to make an axle, I just head into this master sketch, which is basing the whole wheel is in this sketch. And I just make my axle down here, which is going to be very, very easy. So I make a rectangle. And as you know, I'm not drawing it straight, I'm constraining it straight. Boom, 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 boom. And I'm saying that you are collinear with you. And I'm saying that you are, we had, shaft diameter. We have it.
Ba-ba boom!
We have shaft diameter. Boom. But it's now only the radius because of the revolve. So I have to remember to divide it by 2. Boom. And then I want the axle to stick out from the outside of the programming wheel. It's going to be in a frame thing. So let's say 20. And I want to do the same on the other side. So you are 20. And that's all the sketching we have to do to make the axle. What are they saying in chat, Hannes?
Asha feels the urge to teach us how to pronounce Malgosia's name right. I haven't got an explanation yet. And here we are, Machiel van der Toorn. I also traveled from Cape Town to Utrecht to look at the marble machine in the Spielklok Museum.
Wow.
We cycled in the rain to get there, and it was on a day that Chester from Linkin Park died, and there was a memorial at the Dom. Wow, from Cape Town.
Yeah, Magosia played some Linkin Park song on the tower to honor them. Yeah. That's so fun to hear these stories. You will be able to see all the new machines, all the machines at Lukas Wendel's Siegfried's Musikkabinet in Rüdesheim, Germany.
Yes.
Later. We're going to France in May to pack them and ship them to Rüdesheim.
It'll be so fun.
Come on, Fusion. You can do it. So, we're almost done. There we go. There we go. So now you can see my little revolve rectangle there. I head into the new axle component and I only need to do a revolve of this thing. And I need to extrude. Sorry. And I choose the axis. There we go. I'm just gonna leave it for that now. And now comes... So yeah, we did that one. Let's do the CAD axle hubs.
Yahoo!
Let's see. So here's my idea. If you see here, we need good sideways positioning. And we don't want any sideways thing to touch this plywood here. So I want to CAD 2 POM custom sideways bushings. Very simple thing. 0304 POM bushings. And here again, the virtue of the Revolve Master Sketch, we're gonna do them in exactly the same way that we CAD'd the center axle. And now it's so nice because it's so easy to see where we want the bushing. I only have to make a rectangle here, and that is our bushing. I do need to know a distance to the bearing though. So let me head out of here. Okay, so this is one issue. Is that since I'm working in the master sketch, every time I change the master sketch, Fusion is computing all the sweeps and stuff. So this could be an argument for not pushing too many things into the master sketch, but I'd rather like keep it tight and wait a little bit for these computing
Gives
things.
us time to step back a bit, ponder on our ideas, have some water, just enjoying life for a small time.
I'm enjoying that we might have like one of the most important parts almost done in the Marble Machine 3 CAD. Anyway, the first version.
Yes.
I have to write like a new pause song. What should we do? Happy or sad? Sad, of course, right?
No. This is gonna be so upbeat. Here we go.
Upbeat on the music box.
What are you talking about? Oh.
Tell me if it's done.
I'm never gonna say anything. Keep going. Sadly, it's done. Wow!
I forgot the start of it.
Beautiful, Martin.
Yeah. Boom.
Boom! Double boom!
So now I have to take the measurement from I'm just gonna compose the whole album during the live stream, waiting for Fusion to load. Wouldn't that be epic?
That would be so brilliant.
Imagine like all the media engineers. So tell me your musical process. Yeah, I'm doing a lot of CAD in Fusion 360, and like you have to wait when it's like computing because I'm using a lot of master sketches, and those sweeps like circular patterns takes a lot of time to compute. So I use that time to play to make the songs like when I was waiting anyway.
Oh, that's multitasking at its finest.
That would be funny.
All the birds with one stone.
Let me... So, all this just to measure this distance. I want to find out where the bearing... I want to find out the distance from this plane into the bearing here. This is not going well. Measure this plane.
Lucas Wendel, that's the Fusion album then. 10 out of 10, Lucas.
Now I turn the sketch off. 19.5 is the golden number. I should maybe I should have known that. 19.5 was the information I needed. So let's get this done. Master sketch, revolve master sketch. So this distance from here, now where am I? Yes. From here to here is 19.5. And now I can give a clearance, and as I've been saying, 5 millimeters is not a clearance, so let's give it 8 millimeter clearance. And the thickness of the bushing, we decided earlier on that it should be 40, so I put 20 since it's the radius. And then we get these nice 12 millimeters right here for the axle to hang on the bike support. Maybe a little bit too little. I'm gonna work with that now. So we can work a little bit on the Fusion album. I've forgotten it. Yeah.
Wow.
I don't know that key. Maybe more sad. No, that doesn't work. You let me know if it's
I'm
finished.
gonna tell you. You just keep playing.
Sometimes it's fun to play in keys that I'm not used to because I get more surprised. But it also means that I'm pushing more keys that are out of the key.
Pro compute finished.
Perfect.
Nice. There we go.
Now we can make our POM bushings and we're gonna be done when we have... I also want to show you the forks. I will be able to do that. Fusion is a little slow now. So I'm going to the POM bushings and I am using the favorite command, revolve. Choosing that little profile, that little rectangle that we just made. And I'm trying to choose the origin axis. I have to zoom out. I'm gonna take this red axis there.
Uh-oh.
This is not good. This is not good. like the programming wheel on Marm Machine X was horrible to CAD. So it's just please. Yeah, we have the swimming ball. It's never a good sign.
The swimming ball. Swimming ball. Perhaps a beach ball.
That's really Swinglish. That's a worst Swinglish for the whole day. This is going to either crash or never come back, I think. So I'm like 2 operations from being completely done with this programming wheel, and I'm not gonna end it until I am. Yeah. Probably I should make these parts in a separate design and just have the plastic outer part of the programming wheel as a separate design file. So because it's all these sweeps that I've been playing music to, I think they are screwing Fusion up. So yeah, let's go. I'm gonna restart Fusion and I'm gonna get this done.
I'm gonna let the audience take a good look at our beautiful faces instead.
You should leave that judgment to the audience.
I don't care. I just say it how it is.
Especially when my computer screen went red, I get like super red in the camera.
Yeah, ominous.
There, we're back.
Ominous. We're back.
We're back. We are back. So we do not have a recovery file this time. Let's see if that's good or bad news. So to Fusion's defense, yes, lucky. It's these holes that I've made all around. Fusion don't like that. So to Fusion's defense, I know that I am doing stuff it doesn't want me to do. But it would be so lovely if it allowed me to do them without crashing. Here we go, revolving this little thing around this thing. That was all I wanted. There's our POM bushing. So if you can see, the trick here now is that if you look directly from the side, this bushing will stick out and be the only thing that touches the frame of the machine. And we have clearance for all the spinning stuff. So I love to have the bushings in black. So let's choose a glossy paint for the bushing, and we're gonna mirror. I'm gonna move the mirror over. Save.
Oh, that was a fast one. Can you remove the holes for now? People are asking in chat.
Yeah. I can and I should. Good idea. Let me go into the timeline.
Let's disable them for now.
Because I just wanted to check that it worked out. Oh, even maybe disable them. I'm going to delete the holes. These are the triplet holes. Yeah, it's a good idea. I'll miss them, but it's better that we can work with the document.
Can't you just click in the eye and you don't see them anymore? Or that doesn't count?
No,
okay.
Doesn't count. And
Wow.
we're here now.
Oh no. The beach ball of death,
Yeah.
as someone said in chat.
Yeah, I was a little bit. Ooh, it's alive.
It's alive, everyone.
Yeah. I like that thing.
Finished. Oh.
Now.
Oh, wow.
Maybe something.
Yes.
Maybe something
Yes,
little
please.
simple.
Yes, please.
I don't mean to play them, but they fit every time perfectly. It's transitions to this view. So we have some holes removed. I don't even know if I dare to remove the other holes because I'm so close to finishing this one now. So I'm gonna wait with removing the other holes, and I'm going to mirror this mirror feature that we had before. I'm going to include this new bushing. So I'm gonna hold command and push that bushing so the bushing comes into the mirror feature. Come on. Yes, 3. Good.
Yeah, it's speeding up.
So why is it not here? Well, it was a great idea to remove the holes because Fusion already feels better. I don't see the bushing though. Why not? I'm gonna deselect the object. Oh, I'm so stupid. Cancel. It's the whole feature. Here is the. This is the feature I want to mirror. So this is what I mean. If I put the programming, the plastic thing in another thing, we don't have that all the time. So here we go. Come on now, Martin, get this done. 2 objects. Now the bushing is there, and now the bushing comes on this side as well.
Yes.
Took me some time, but we got there. I want to show one last thing before we're calling this completely done. Is that I can show it on the sketchpad in a while. So let's put sketches off here. And look how clean this looks.
Ooh.
And the axle stays on here. You could even screw it on with this little set screw here. So no stop rings needed, nothing, thanks to that beautiful little set screw. And as you can see, when we check it from the top, it sticks out. So if we go over to the sketchpad, I'm just gonna delete all this. So you know how a bike wheel looks? Something like this. And we can basically just have this. Oh, wait. That's ugly. Imagine, look like cactus on the desert. Imagine there's a frame like this on the machine. And here we can basically just have some piece like this. Boom. And then comes the big programming wheel here. With the spokes like this. And here sticks that little 10 centimeter of the shaft out. And we just slot it into here. So we just lift it in place, let it fall into place, and it's mounted from the back of the machine. When we want to take it out, we lift it out. Perhaps we want a little lock pin here or something. But you see, it's not inside the machine, it's just on the back side of the machine.
Wow.
Like bike thing. I think this is really brilliant. I'm really happy about this. So I'm gonna say that we're actually done.
What?
Thank you so much for tuning in with us. We have a beautiful simplified programming wheel and a simplified way to change them between songs. And I'm really excited that the pulley is back on the programming wheel. Thank you, 3000, and thank you, chat, for helping out.
Yeah.
See you on the next one.
See ya.